Okay, we have two hydrogen gases and an oxygen gas, and we're going to make two liquid waters, and it's important that they're liquid. You're going to get a different value if you try to use water vapor. Alright, so ultimately what we're doing when we use Hess's law of summation is we're finding out how much enthalpy it takes to tear apart each of the chemicals, each of the compounds, until we get to their elements. Now, that's given by the delta H of formation. Now, the delta H of formation of hydrogen gas is 0 kilojoules per mole because it's an element and it's a gas at room temperature. If it was hydrogen, if it was H2 as a liquid or H2 as a solid, that would be something different because that's not the state it is at room temperature. Oxygen is a gas at room temperature, oxygen is an element, so that's also going to be 0 kilojoules per mole. Now, water is a compound, so there is a delta H of formation, and we take a look and we'll notice that we have a delta H of formation of negative 241.8 kilojoules per mole and another one for negative 285.8 kilojoules per mole. So what's the difference between those two? Well, one is for a gas and one is for a liquid. So we need to use the liquid. So we have negative 285.8 kilojoules per mole. So that means that when we form, because this is a delta H of formation, when we form 1 mole of liquid water, we release 285.8 kilojoules. So if we form 2 moles of water, we would release twice that, 2 times 285.8 kilojoules. If we look on the reactant side, it takes 0 kilojoules to break hydrogen down to its elements, because it's already at its elements. And oxygen, it takes 0 kilojoules per mole to break it down to its elements because it's its element. So we have to put 0 kilojoules in, and we get 2 times negative 285.8 kilojoules out. So it's going to be fairly simple that the answer is going to be somewhere a little bit smaller than 600 kilojoules. But we can't just reason this out. Okay, this is a very simple example. We can figure this out in our heads. We need to use a formula. So here's our formula. The delta H of the reaction is equal to the sum of the products minus the sum of the reactants. Okay, so on our product side, we have 2 times negative 285.8 kilojoules per mole. And on our reactant side, we have 2 times 0 kilojoules per mole. And we have 1 times 0 kilojoules per mole. So the math is quite straightforward here. So we have 2 times 285.8. We have negative 571.6 kilojoules per mole minus 0 kilojoules per mole gives us negative 571.6 kilojoules per mole. Okay, and if we want to look at significant digits, because of course, why wouldn't we? The number here has 4 significant digits. We're multiplying it by 2, which is an exact value, which means it has infinite number of significant digits, which means this is going to have 4 significant digits. We have nothing here. By definition, nothing is exactly 0, 0.0 to the end of time. So it has as many decimal places as we need, which means our answer is going to have 1 decimal place.